Good morning, everybody. Thanks, Todd, for the introduction. As he said, my name is Matt Taddy, and I'm the Vice President, the leader of worldwide Amazon Private Brands. And I'm super excited to get to talk to you all this morning. Two purposes here. Purpose number one is really to introduce myself and Private Brands as part of the Amazon business value proposition, right? So that you recognize what we can bring to the table and how we can be part of your journey to use Amazon Business. The other thing that I want to do, the Reshape organizers thought that with my kind of specific nerdy professor background, I might be able to give some lessons about what I've experienced and what I've seen, trying to bring science into business at Amazon, into Private Brands, and give you some best principles and some ideas as to how you as leaders might integrate more machine learning and artificial intelligence into your businesses. So first of all, what is Private Brands? What is Amazon Private Brands? Well, we're a part of Amazon that builds things. We make things. We make products and brands that customers love and trust. We do that by making deep investments in quality, safety, and sustainability. We do it by laser focus on our cost structure, on working on cost out with our suppliers so that we can get you that safety, quality, and sustainability at sharp price points. And because we're Amazon, we find ways to get those products to you in the format you need them, where you need them, when you need them, wherever that might be. Okay? We have about 40 brands, over 40 brands worldwide. What I've thrown up here on the chart is some of our larger brands in the North America, US market. A couple that as business customers you might or should be familiar with that I'll call out. The big one right in the middle and the top is Amazon Basics. This is our largest brand, right? It covers a huge swath of products, and it comes from the basic premise that customers should be able to get basics, everyday essentials, the staples, the things you need at high quality for low prices, okay? And like I said, it covers a really wide array of products from the razor that I used to shave this morning, to the charger that keeps my phone alive, to a product that might be familiar to many business customers, our copy paper. If you're not familiar with the copy paper, 115,000 reviews, 4.8 stars, really great price point. It's really good copy paper, okay? Another one which is smaller, newer, and growing quickly that you might want to be familiar with is Amazon Commercial. Same premise as Basics, right? You want to get quality, what you need at sharp prices, right? With Commercial, this is growing out of our relationship with Amazon Business, where we're learning what are the specific grades, specific types of products, and specific formats that are suitable for the business customer and are needed by the business customer. And so we're kind of taking both approaches here. With Amazon Basics, we're looking at our consumer products and saying, how do I adapt the formats and get this into a place where my business customers can use Amazon Basics in their Jansen, in their break rooms, in their offices. And then we're also saying, okay, what do we need to do, working back from the customer directly to fill in B2B products that we don't have as an organization that started, consumer focused. So can you go back a slide? All right. I'm missing a slide, but I'll talk over it. So the next part of the talk, which is not just about Private Brands, in the title we also had data science, right? And so what's going on here is Amazon uses science intensely in everything that we do in order to solve problems for customers, okay? I have a peculiar background which would probably only happen at a place like Amazon in that I'm a scientist. I'm a professor for 10 years. I started out in aerospace, as Todd said, and I moved over to Amazon, and now I run a big, manufacturing organization, right? And that makes sense at a place like Amazon because we approach problems with a scientific methodology. We work back and we try to apply data and we try to apply the best possible technology in order to come up with the best customer solution. And so my peculiar background is when I came into Amazon, I first came in with a title of chief economist, right? Which felt a little bit uppity to me. I never really felt comfortable with it, but it was a fantastic job. And one of the things that we did as part of that office of the chief economist is we created this organization called Economic Technology. And the charter of that organization was to go around throughout Amazon to places where we weren't currently using science, where we weren't currently using automation, and try to inject good science data-based thinking into those parts of the business processes, into those parts of the operations, right? And so not going after places like search algorithms or ad targeting, places where there are established, clear science problems, but going after the things that are probably familiar to many of you, call centers, negotiations, right? Pricing, curation of clothing, for example. So just places that weren't naturally set up. And then we say, okay, how do we break this down into a set of problems and start to bring data to bear and get better outcomes for customers? And so the idea of the Reshape organizers was that I could tell you a little bit about what I've learned through that process and how we are applying that in private brands to make that work better for you. So that's what we're going to work through now. All right, so the first thing that I'm going to talk about, so I have a picture of an old electric motor up here, and I'm going to explain why I have the old electric motor up there. The first thing I want to talk about is what do I mean when I say science? Let's make this a little bit more concrete, right? It's a data science in the title. That's a buzzword that can cover a huge variety of things. To keep things simple, what I'm talking about today are tools for making decisions and automating decisions, so tools for automation that include learning from data as some element of them. They include machine learning as an ingredient in how you do that automation. Okay? Now, machine learning itself is this massively broad term. It covers everything from what was formerly known as statistics when I was a statistics professor, now to things like deep neural networks and deep learning, the techniques that are popularly associated with artificial intelligence, right? And so machine learning covers this really broad swath. But as leaders, what you need to know is that it does one very basic but powerful thing, which is it detects patterns in data. Okay? So you have data, comes from the past. Machine learning detects patterns in that data. And so if you want to use machine learning for automation, you have to set up your processes, set up everything that you're doing so that patterns from past data can be made useful for predicting the future and automating what you need to do in the future, right? So understanding that basic form of machine learning and the limitations of that basic form are essential for what you can do in order to change how you operate to admit machine learning as a source of automation. And I like to draw an analogy to the electric motor. This is why this is up here, right? So this is from like late 1800s. When the electric motor first came around, did a very basic thing. It still does a very basic thing, right? It turns electrical energy into mechanical power, right? And when that first came around, it's not like you could just go to the existing factories of the day that were steam operated and pull out the coal furnace and swap it in for an electric motor, right? It didn't work like that. You had to reinvent everything in the factory line, right? Every machine, every process had to be reinvented and built up from scratch around this new source of energy, this new source of mechanical power. And that's why economic historians refer to inventions like the electric motor as a special class of inventions. They are themselves methods for invention. Okay? So the electric motor is a method for invention because it itself was not inherently useful for end customer productivity. It itself did not increase productivity, but it created a whole ecosystem of inventions, new ways of building things powered by that method for invention that led to just an absolutely fantastic increase in productivity. And machine learning is the same thing, right? In and of itself, you look at some past data, you figure out some patterns. It's not that useful. You can't take an existing business world and just throw some pattern recognition in there and hope for the best, right? You have to change how your business operates, how your processes operate in order to admit that automation and admit use of machine learning. Okay, so I'm gonna try to give you just two big principles that I think, when I distilled it down, are the two big ones that help me figure out when I go to an area that's not currently using machine learning, what I can do to get machine learning in there, get science in there, and get good outcomes for customers, right? Number one is you need good data. Now that sounds like crazy simple. Well, of course you need data. It's machine learning. It's called data science, right? But it is very rare that you can just look back at data that was acquired from business as usual and use that as a foundation for good forward-looking automation. It's exceedingly rare, right, that patterns from the past are just instantly going to be useful for making decisions and predictions about the future. And so you need to, as leaders, you need to make sure that you have an active strategy of data generation for any application where you're going to start deploying machine learning. Give you a couple examples, right? First one, pricing, okay? So, standard problem in all businesses, problem that we face at Amazon. How do you understand customer responses to changes in price? Okay, price elasticity. Classic machine learning problem. It's also notoriously a place where looking back at business as usual gives you patterns that are not useful for understanding how customers will respond in the future, right? I'll give you an example. We're sitting here in a hotel, kind of peak season, beginning of peak season for conferences in Arizona, starting to get cold everywhere else. It's still super beautiful here, right? Reshape, I'm sure they're frugal, they're Amazonians, they got the best rates they could, but it's probably pretty pricey, right? Also, the hotel is full. That's probably true of all the hotels around here. Prices are high and hotels are full because demand is high, right? If you look back in the middle of the summer here, you go back in July, prices were low, hotels weren't full, okay? Well, it's because underlying demand was low. If I tell a naive machine learning model to learn customer responses to prices, fit to that data, it's gonna say, hey, when prices are high, sales go up. When prices are low, sales go down. Of course, that's garbage, right? Because what's happening is there's an underlying demand process, and the prices and the sales are both responding to that, right? But that's why just looking back at business as usual practices is not useful for building a machine learning algorithm that will predict customer responses to price changes in the future. The same thing happens on Amazon, right? We have overstock because demand's low, we need to clear out some inventory. You have a situation where sales are low and prices are low in the history, right? And so this business as usual data, these patterns there are not useful for the future. So what you need to do, for example, which is one of the ways that we incorporate into our pricing in the private label business, is you need to introduce some randomization, some experimentation. Now, on Amazon.com, everybody always sees the exact same price, where it's not like you have one price and you have a different price, right? So we don't experiment in that way. But what we do is we change prices from week to week, like any business does. Day to day, week to week, prices move. And what we do is when we change those prices, we deliberately sometimes introduce a bit of random variation. We don't change them according to a fixed rule. We run somewhat of price experiments. We make it maybe a little higher, a little lower than we would think. And those small changes allow us, through experimentation, to not just have business as usual data when we look back, but actually to have signals of how customers respond to price changes, right? And so that's an active data generation strategy. That's the experimentation that I'm talking about. I'll give you another example, which is very important for private brands, which is customer feedback, okay? So as Amazon private brands, I feel that we have a mandate to take advantage of the massive amounts of customer feedback that you get on Amazon.com, right? And through our customers. We have huge numbers of reviews, ratings associated with that reviews, return rates, right? We get a ton of information on Amazon around how our products are working out. And we have a key differentiator for Amazon private brands needs to be that we connect that information to the production of our products so that we close the gap between customer feedback on a massive scale and the quality engineering, the manufacturing processes through which our products are produced, right? So that, I think, needs to be a key differentiator for us and for you guys all as customers of Amazon private brands. Now, how do you do that? Reviews, feedback, customer feedback is messy. There's massive volumes of it, which is great, but it's also messy, right? It's not all useful. And you need to pick up patterns in that. So you use machine learning in order to generate insights from that massive amount of customer feedback, right? The thing is, you can't have that just go one way. An ML that generates the insights from the customer feedback, passes that to manufacturers and quality engineers, and that's it. That's a one-way process. What you need to do is create a loop so that you actively validate those insights and actively generate data around the quality of those insights. So what we need to do is wire it up so that anybody receiving those insights, quality engineers, suppliers, manufacturers, is able to hit a button, tag it, and say, yes, useful, not useful. That's it, right? But something like that closes the loop. Refer to it as human in the loop. It closes the loop so that now your ML that's generating insights from the customer feedback is able to improve on a continual basis. It's able to experiment. It's able to say, hey, I have a bunch of information from customers here. It doesn't look like an insight to me, but there's something. I'm going to try it out. I'm going to throw it. And then the humans could say, yeah, you know what? That was useful, right? And then it knows next time it sees something like that, it can generate it up again, right? So experimentation, human in the loop. Just always be thinking, how am I generating data in order for my applications to work better? The second one here is that metrics matter. Okay, so this is going to be my second big one. Now, most of you are probably, well, no duh, metrics matter. I'm a business leader. I know that, right? And that's true. You're all like very accomplished business leaders. And so I think most all of you know that metric-driven leadership is essential. Having good metrics and setting goals against those metrics, that's how you get top quality, decentralized leadership, right? That's how you have it so that you can tell your teams what to do, what you want as outcomes rather than how to get there, and let them invent, right? So we all know metrics matter. We also know that metrics in business, the process of defining those metrics is super, super crucial, right? How do you define metrics? Well, first you say, what are my big customer backwards problems, right? What are the problems that I need to solve? I don't know. In one environment, that might be, I want high customer engagement with my product. In another environment, it might be like, I want the most efficient processes, right? Efficient production processes. Well, you can't measure customer engagement or efficient processes directly. So what you do is you measure things that are related to that, right? So, and those are your metrics. You measure, I don't know, monthly active users, for example, or on-time completion rates, or percentage of rework in those cases, right? And those are the metrics that you measure, and you start to drive against those. As leaders, you know that you have to always be skeptical of those metrics, right? You want to make sure that driving that metric is going to get you where you really want to go, which is high customer engagement or efficient processes. And so good metrics-driven leadership, there's always this process of validating, right? Okay, as we drive this goal, are we really getting to where we want to go? Is this the right number to be targeting, right? And you question that, and that is how, as a metrics-driven leader, you insert your context and your judgment into the business processes. Now, it's the exact same thing with ML. Whenever you have a machine learning algorithm, you're using data to predict something and optimize something. That something, those are metrics, right? But I've seen a lot of, this is a pitfall, I've seen a lot of very experienced leaders who would be hitting any metric that they come across in a business review or anything with a huge amount of questions, huge amount of skepticism, really leaning in with their leadership on what those metrics should be, hit the ML and be like, okay, the scientist chose something, must be good, right? And that's totally not the approach you should take. This is what the ML is driving, what the machine learning is trying to predict, that is where you have a chance to input your business judgment, your experience and your context. And so use that. That is kind of the lever that you have. I'm gonna give a couple examples of this one. Okay, so first one, return rates, right? And so this is kind of a real example from that economic technology world that I talked about earlier. You want to reduce return rates on products. Returns, they're not great for customers, they're expensive for Amazon, nobody likes them, right? And so what you might naively do is say, okay, well, I'm gonna build an ML to reduce return rates. What I've done there is I've said return rate, the thing I'm gonna try to predict and reduce, is my metric, right? That's my headline metric, the metric that I'm ingesting into my machine learning algorithms. The problem is, return rates and things are returned for reasons that are connected to the products themselves, the product type themselves. Like, clothing. By the way, this is an Amazon Essentials t-shirt, also very good t-shirts. Clothing, just because it's clothing, is returned at a higher rate. Fits hard, right? Things that cost more, higher ASP, higher price points, are returned at a higher rate because people return higher consideration purchases more frequently. And so if you just naively get out there to train some machine learning algorithm to reduce return rates, the first thing it's going to do is stop selling clothing and high-priced items, right? Which is not what you want. That's not at all what you want, right? What you want to do is build a metric that you can reduce that's going to improve the customer outcomes. And in this case, it would be something like what we came up with was returns over expectation, right? So any of you familiar with baseball or hockey stats, there's the ideas of, goals above expectation or hits above expectation. Same thing with return rates. You kind of know for that product, that price point, what we should expect as the baseline return rate, and you try to reduce return rates relative to that expectation rather than overall. So I try to reduce the t-shirts that are returned at a much higher rate than I would expect for t-shirts rather than just stop selling t-shirts overall, right? And so that context, that judgment of how return rates works, that's a key piece that you as business leaders need to have in mind when you're thinking about what your scientists, what your data scientists are studying and optimizing for. And they won't have that context, I guarantee it, okay? The second one is very important at Amazon, which is long-term thinking, okay? Number one pitfall I've seen in deployment of machine learning in business environments is that the metrics you're targeting are too short-term, right? And this is not an easy one to deal with because you don't get to see the long-term, but you have to invest time in making sure that the metrics that you're targeting are things that, if that goes up, it leads to a long-term healthy relationship with customers, for example, in a customer-facing setting, right? So think back to anything that I would show to customers, deciding what products to show them, how to price things. I'm interested in, but it's not the headline for me what that customer clicks on next or what they do next. What I'm really interested in are the metrics associated with what the customer does next that give me indications of a healthy long-term relationship with that customer, right? Did I acquire a new customer to a new type of product? Did I increase loyalty or repeat purchasing within a brand? Things like that, right? And combining metrics together like that to make sure that the machine learning systems that you're building don't become short-sighted. All right, so 2 principles: generate lots of data and invest in your metrics and inquire about your metrics. The trick to doing this right, of course, is also picking your problems and adapting your business so that you're attacking areas where that's possible, where you can generate lots of data and where you have strong metrics. So I'm going to quickly give you 2 examples, right? When I first moved to private brands, one of the things I heard repeatedly was like, oh, hey, science guy coming into private brands, are you going to build a robot that designs products? That would be pretty cool. But no, it fails like my 2 things. 1, I don't generate that many products, right? We only launch, hundreds or maybe thousands of products a year. And it's very expensive. Now, I'm not going to experimentally launch a bunch of products just to test out the ML algorithm. That's going to damage my relationship with my suppliers, damage my brand, right? So it's an area where acquiring and generating data would be extremely expensive. I'm not saying it's impossible, but it's not going to be the first place that I'm going to go look as like an easy place to deploy machine learning. And the second one is it's a very difficult metrics environment. It takes a long time to see if a product is a real winner, right? It takes time to ramp, takes time to build up a customer base. And so if I'm going to get in there and have anything other than very short-term metrics, I'm going to have to invest a ton of science in understanding what the leading indicators are of product success and try to have those be the things that fuel any machine learning. Right? So maybe possible, but probably not where I'm going to go first. Where I'm going to go first, it's probably good news for everybody here that buys from me, is looking at my cost structure, right? So tons of metrics around the prices I should be paying for products. What do raw materials cost? That's a forecasting problem with very clear metrics. What are my manufacturing metrics, right? Like margins above raw materials, the returns to volume and scale, all the things that everybody here who makes things is very familiar with, right? Very clear metrics, very clear prediction problems, come up with data science in order to predict what those costs should be, and then compare the cost targets that your machine learning tells you to what's actually realized. And lots of humans in the loop. We have RFQs going out all the time. We're negotiating on prices all the time. We're talking with suppliers all the time. Suppliers value transparency in how we think about costs, right? And so there's tons of humans generating data in this space. So it's a rich place for us to deploy machine learning. Okay, and so that's the mental model about thinking about where it's going to be a nice, easy road to ML and where it's going to be pushing a rock up a hill. All right, so last topic, I'm going to switch gears a little bit here, and I'm going to go to, for those of you who ski, the double black diamond of science integration with business, which is environmental sustainability, okay? I was trying to find pictures for this slide, and so I decided I'd share a silly Tatty family anecdote. On vacation, we actually look for big old trees. We go kind of like up in British Columbia where my wife and I are from, and here's a couple of big old trees from this summer's trip. The one on the right is like 800,000 years old, and the one on the left is actually reportedly 2,500 to 3,000-year-old cedar tree up the north coast of BC. Anyways, that's where my pictures came from. I care a ton about sustainability. One of the reasons that I took the role with Amazon Private Brands and jumped from science into this was because of the challenge of creating more sustainable products and using us as a manufacturing organization to pull carbon out of Amazon's footprint and out of our customers' footprint, okay? And now how do we do that is a very difficult integration of business and science, right? To pull this off, you need to have really strong measurement on the key metrics. The key metrics are on the output, what the carbon impact is, right? On the inputs, measures of the levers that you can reduce or increase in order to reduce that carbon footprint. Use of renewable energy, raw materials, different transportation modes, okay? Metrics associated with all of those inputs. And how this works is you need to build a measurement system that connects those inputs to outputs so that I can go to my suppliers and say, if you make this change, it's worth this much in a carbon reduction, okay? And then I can go to my customers, to you guys, and say, if you switch from this to this, because my supplier did this, this is the reduction in carbon. And you can pass that along to your customers. So that whole chain, carbon out in that whole chain of business, relies on us all having strong measurement. And I think Amazon has a real role to play here in leading in that measurement space. So how this works in terms of the science is that you have these science models. We have a large science organization at Amazon that builds models that connect inputs, raw materials, in order to predict for a process that uses this energy source, uses these materials, manufactures in this way, this is the carbon impact, right? It's got to be modeled, otherwise we can't set goals around the inputs. But then you also need to generate data. And the way we do that is you take individual products, t-shirts, batteries, charger, whatever, and you do a deep, not modeled, but deep kind of audit on what is the environmental impact of that product, okay? And that gives you a much more detailed, hey, this shirt came from exactly this address to this address. It came from these, these raw materials came from this batch. They flew through this mode, or were hopefully not flown, shipped through this mode, right? And that allows us to build up a data point. That data point can be compared to what the model predicted, right? And so we have this great process where we go out there, we have science models, we sample with these great, deep product audits, and then we connect that audit information, compare it to what the model said, and that allows the models to improve. The scientists can say, oh, okay, well, I screwed up. I thought t-shirt impact was higher than it was or lower than it was. They take that feedback to build better measurement models. And that auditing, that sampling, so active data generation, allows us to build trust in the measurement models. So the same principles, even though it's the double black diamond, it's sustainability, and we're kind of at the early days of this for all of us. It's the same basic principles that we always use for deploying data and science in a business setting. Okay, so there I will wrap. Hopefully some of this advice is useful. Like I said, they kind of set me up as the professor at the 9 a.m. meeting, so I hope that was okay with your first coffee. The one thing I'll say, just kind of, again, introducing myself and Amazon Private Brands, is that the B2B space, as you know, it's kind of new for Amazon. It's also new for Amazon Private Brands. We are extremely excited about it, right? Myself and my team are here. We want to understand what products we need to be making, how we need to be making products, how we need to be measuring things in our product production process in order for that to help you get more out of Amazon Business, right? So I really want us to be a strategic differentiator for Amazon Business, such that when you come and see the basket and what is possible with Amazon Business, APB, Amazon Private Brands, is part of that proposition. So anyways, thank you guys very much.